Good afternoon and welcome to today's webinar, a deep dive into pressure sewer systems ownership costs. I'm Will Stradling with Siewert Equipment and I will be your moderator. Just a few housekeeping items before we begin. During the presentation, there will be a couple multiple choice questions to answer by poll vote. You will click on the answer that you think is correct, hit the submit button, and we'll post the results and move on. To receive your operator and PE credit for this webinar, you must complete the poll questions during the presentation. In addition, please feel free to type in your own questions anytime in the questions drop-down arrow on the dashboard, and we'll do our best to answer them during the presentation or at the end as time allows. To receive your PE credit for this webinar, you must complete the survey evaluation that will show up at the end. So please stay connected until you complete the evaluation. You can go ahead right now and download your certificate of completion and fill it out. Make sure you grab the right one. There's one for New York and there's one for Massachusetts. You can also download a PDF copy of the presentation. These are available under the handouts drop-down arrow. If you missed downloading these, please contact Sherry or she'll attach them to an email that she sends to you at the end. Please be sure to check out our Siewert Equipment website and follow us on Facebook and LinkedIn for more information. Well, that wraps up the announcements. I'd like to introduce Henry Albro as our presenter. Henry is a senior sales and application engineer with FR Mahony in Rockland, Massachusetts. He's been with FR Mahony for over 20 years, and previously that he was a sewer superintendent for another 20 years. He has a bachelor's degree in civil engineering from Vermont Technical College and wastewater operations studies from UMass Lowell. He holds a Massachusetts grade 7 wastewater license and a grade 4 NUWEA collection system license. Well, thanks everyone, and enjoy the webinar. Over to you, Henry.
Thank you very much, Will. I wanted to make sure I can advance a slide. There we go. So the webinar that we have today intends to look at long-term ownership costs for a large pressure sewer system. The system we have is over 450 pumps installed. In this, we will look at some background studies that have led us to what we've done this year, look at some reference papers and presentations that we've done as foundations to this effort, and we will look at the service history and costs of maintaining this large system over a 15-year life. The results of this would be to actually show the beginnings of an asset management plan for the community that we are evaluating. So I guess the question is, what is asset management? And asset management, this is directly from the EPA website, who are big proponents of asset management. And it's a process for water and wastewater utilities to basically plan for future capital expenses, maintenance of their systems, their pumps, their motors, the pipelines, so that things can be repaired and upgraded in a timely manner, rather than doing it in a catastrophic emergency type repair. It's a planning tool. Asset management is the practice of managing your infrastructure, just looking at long-term what your needs are, developing a rate structure that would enable these utilities to sustain their systems, to make them sustainable over the long term, and to provide inventories of all your assets, maintenance tasks, and long-term financial planning. So the foundation for all of this work comes from papers and work that were done in Chelmsford, Mass. And Marion, Mass. These two communities are both about equal in size for pressure sewer systems. Chelmsford, Mass. And Marion were the focus of papers that I helped work with from 2014 to 2017. We'll discuss those briefly. and then look at how we develop the information through our data mining of our database for service records, and shows the Chelmsford study actually provided the foundation for the deeper dive that we'll discuss at the end of this for Marion, Mass. So Chelmsford was presented at the New England Water Environment Association annual meeting in 2014. And the session records are available through NUIA for those who would like to see that. The findings were then presented in greater detail in the NUIA Journal article, spring of 2015. And that is another article that is available online at the nuia.org website. Chelmsford pressure sewers, they were built from 1999 to 2013 over several contracts that were bid. They did several different project areas that were deemed inaccessible by conventional gravity sewer and pump stations. And the pumps were then purchased by the town and then given to the residents who were the private owners of those pumps and controlled the maintenance of those systems. Predominantly, service was provided by F.R. Mahony and Associates. Our company was the main contact person for service. Because residents felt that the grinder pumps were part of the system and should be owned by the sewer entity, they formed a Sewer Fairness Alliance group, which had a lot of social media through Facebook and gathered a lot of information and presented a lot on their Facebook page. They ultimately brought a town meeting vote to have the residential pumps maintained by the sewer department. Chelmsford has a representative town meeting, and that action passed, and Chelmsford then became the responsible entity to maintain grinder pumps. All this was brought on by certainly some legitimate concerns and issues. You know, the one-time repair bill that a homeowner would get, similar to if you were to take a vehicle into a service shop and get a big bill to replace a transmission or something like that, versus say a warranty plan where you pay a little bit a month or a little bit a year, and then the costs are absorbed. And I think that's essentially what transpired in Chelmsford. The sewer rates cover the cost of repairs, and the homeowners actually aren't presented with a repair bill. So it took a lot of that fear and anger away from the residents. So the private service work previously being under the control of the residents, many of the repairs were limited to the ability of the residents to pay. You know, if they were given options that they needed certain repairs to get by or full repairs, they would often pick the cheaper alternative to just kind of limp things along. Some of the systems during the political transition of ownership were completely neglected, so that you know, pumps could have been almost in complete failure by the time the town took over. So what Chelmsford did was they actually went out for a services contract, and Weston and Sampson Services, local to the area, was a successful provider, and they have a renewable 3-year contract that I think is in their second and at least third time period now. Part of the evaluation of the system to assess what was going on in the system, to figure out where their needs were, had to be done. They had to kind of do a top-down look at all of the pumps to determine what priorities need to be established. F.R. Mahony was a local distributor who provided support and replacement cores. We also provided service training and support to Weston and Sampson directly. So the first question, I guess I will do this, is asset management is used to, and here's your poll question. So what do I do?
I'll take care of it.
Okay.
So please answer A, B, C, or D. Okay, over 80% of you have voted. We'll give it a couple more seconds. Okay, I'm going to close the poll, share the results. D, all the above. Back to you, Henry.
Hey, everybody was listening. That's good. So Weston and Sampson, the town of Chelmsford, and FR Mahony presented the results of this top-down evaluation and the first 3 years of service work that was done in Chelmsford. They used an app we used in our system, their iData Collect, to ask a series of questions when they went through a site. And what you would see is they would take pictures of the alarm panel, pictures of the core, documented basically every individual location. And that served to be a very good tool for setting priorities, and it's something that we use in all of our service activity today as well. So the history again in Chelmsford was about 525 residential grinder pumps, predominantly Environment 1 product. There were some Myers, Barnes scattered in some private projects, and these were all privately owned until they became town maintained. So the town did a full inventory and condition assessment of what was where and what condition it was. They identified the parameters for evaluation. What questions do they ask to try to be consistent in collecting the data? Look at the historical issues, residential calls. So they went through past service records, identify current potential problems the system would need so they could establish any budget needs or budget solutions. Identify potential problems, evaluate deficiencies from town standards. There are town and manufacturer standards for installations, and some of these standards were deviated, causing issues with the installations. And they wanted to track the installation accessibility issues, which we'll show in this next slide some of the things that were discovered. So we have the creative fire pit in the patio for access. Under the deck, I don't know if there's a hatch above this one, buried in the bushes or buried covers. So things that were found like this were noted. The homeowners were instructed to have these things changed when they could. And some of the pumps couldn't be accessed by the service provider, and they were noted to the homeowner that their pumps just couldn't be serviced the way they were. So some of the things that were discovered. So here's our next question. Take it away,
Okay.
Will.
What year did Chelmsford, Mass start installing grinder pumps? Please choose A, B, C, or D. Okay, over 80% of you have voted. I'll give it a couple more seconds. I'm going to close the poll and share the results. D, 1999. Back to you, Henry.
Thank you. So in the categorization of the priorities in Chelmsford, they found that 81% of the pumps were in fair to good condition, and that there was roughly 9% that had some severe issues. And the squeaky wheel gets the grease kind of comparison. These were the areas where they were hearing the loudest complaints and causing big concern amongst the neighbors. Some of the issues that were identified were certainly grease, light grease or heavier grease in the stations, and then another look at debris, trash. A sewer system is not a solid waste disposal system. It is a biological process, and wipes, certainly under 2020 with the COVID issues, are being a big problem in a lot of systems, not just these. So debris, trash, those items were identified, and the homeowners were instructed not to continue to put those down the drain. The repairs, some of the repairs were done on site during the inspection, some minor repairs. There were some critical repairs that were noted from either neglect or age. Some deficiency repairs with installations, whether it be a grating, sealing, a conduit penetration, things of that nature. So they went through stem to stern all the pumps in Chelmsford to get them back up to standard. So they defined the parameters for repairs, they determined the criticality, prioritized their efforts, grouped them into either multiple repairs in the same pump, or they went by neighborhood, they'd work on a particular street for the best efficiency. The cost of this initial service dramatically dropped off in their later year maintenance. They've actually found good success with their initial efforts. The benefits of the system were that they've reduced their callbacks dramatically. They are sharing best practices with installers, with inspectors, and with the residents. They're looked at the proper grading of the stations, sealing conduit panels, making sure that alarms are functioning properly, educating the residents what not to put down the drain, and they developed a plan for replacements. Any pumps that were over a certain age, they wouldn't waste money on repairing, they would replace them. And they stuck with a preferred model to standardize for repairs and for spare cores and so forth. And again, the stress that came from my co-presenters at the spring meeting at NUIA was that pictures are worth 1,000 words. A homeowner can be shown directly what's going on in their station with just a few carefully taken pictures. The mean time between service calls, this item at the bottom here, MTBSC, of 13 years from the initial study in 2014 has actually improved. We don't have specific data because that's owned by a private service provider. So the reports that we get are that the return calls and the reliability has dramatically improved. So here's your next question.
Okay, I'm going to launch number 3.
When the next question will come up the next slide, Will. So I just want to show everybody that mean time between service calls, if you're paying attention, I warned them. How's that? So you take the number of pumps in your system times the total years of service divided by the service calls for that entire period of time, and that gives you a mean time between service calls. And the Environment One providers usually state mean time between service calls of 8 to 10 years in all of their projections for individuals purchasing these systems. So here's your question.
Okay. Actual operating data is choose one, A, B, C, D, or E. Okay, where 80% of you have voted. All right, I'm going to close the poll. share the results. Henry, do you want to expand on this?
Sure. I
So,
threw you a little curveball. I think that actual operating data is certainly all of the above. It's very helpful. It's useful for public education when you have to answer the residents' concerns or questions that come up. It's useful for project management or part of the asset management, figuring out where your costs are, where your issues are. And useful for your asset management when you're planning the long-term life. So to me, all of these items are important, they're helpful, and there's probably a lot more that you could add to this. But for the sake of a slide presentation, these are, I think, the big bullet points. How's that? So let's talk about Marion. This is the area where we did the deep dive. This project was designed by EarthTech, who is now AECOM. I wanted to make that point clear. There were presentations that were done at the NUIA 2006 meeting in January, their annual meeting, and it was also presented at WEFTech session 50 in 2007. And this was basically a description of the capital cost, the project, how it came about. That was the benefit, what was the benefit, and what did the residents and the community see for advantages. That white paper followed WE&T in February of 2008, Beyond Gravity. It was based on a white paper that was done by Deb Mahony, Tom Parise, Jay Hall, and Robert Zorro from the town of Marion. Things that they had learned from their pressure sewer project, which at the time was the largest low pressure sewer project constructed in New England at one time. There are larger systems combined. Chelmsford is equal over a longer period of time. So Marion had 455 pump systems serving in 3 service areas of town. There was the Derry, Dexter Beach area, and South Converse area. And that project construction was completed in 2006. And then there's been some small additions over the years, bringing their population to around 471 pumps. The low pressure sewer was compared to a gravity, and this was taken directly from the WEFTech presentation by AECOM, showing that what happens here was they looked at the cost and had to present and educate the residents who had to finally vote on the final selection of what they were going to put in, the cost benefits of pressure sewer over gravity. So 46,100 feet of low pressure sewer replaced 49,900 feet of gravity and force main, and they eliminated 21 lift stations by having the individual grinder pumps on lot. That saved them a lot in siting, trying to locate where a pump station would be, and the ongoing maintenance. This is a direct quote from the conclusions of the paper that AECOM EarthTech presented. And the bullet points are as they actually decreased the project cost by about $43,000 over what was estimated. And that in addition to the successful timeliness of the project, they reduced the betterment assessments to the residents by around 22%. So they had a good budget, they had a good estimate up front, and then things worked out very well. They acknowledged that the Board of Selectmen, the Public Works, Building Department, Board of Health, all worked well as a team to make this project successful. So Marion, how it came about was a state revolving fund loan that required them to maintain the grinder pumps for the life of the loan. And so that forced Marion into a contract service agreement with, ultimately with FR Mahony by price bid. The general service results that were presented along with the Chelmsford study in 2015, 14 and 15 were used as kind of a basis for what we're going to be discussing here shortly. The sewer system management managers, actually in a conversation that I had with them last fall, was that they were trying to grasp what they would do, how they would maintain the system. I don't know that their records actually held everything in place. If they had a kind of a storage area of all their records and they hadn't compiled anything. This was something that was lacking. So the initiative that I took was to go through our records and compile this study that took place over the slow holiday season this past year. So 2021, let's take a look at what we were able to put together. I developed an in-depth worksheet that listed all of the property addresses, the pump serial numbers, the date of the installation, when it was started up, if there was a issue with the startup, those were noted. Then the date and time of the first service call, the date and time to additional service calls. So we're tracking each location through its entire life. We looked at the breakdown of service issues, what caused a failure, what caused a service call. We identified repeat issues so that we could now begin a plan to focus on some of maybe the troublesome locations. We tagged those locations and put that in the final report to the town where efforts need to be looked at immediately. The other issue is we looked at the depreciated value of the pump and the core. We looked at the life expectancy, and is a pump on a straight line depreciation worth spending a lot of money for repair at a certain age? So this is something that will become part of, we hope, their future asset management planning. So the results of all of this, we have all of the spreadsheets and everything put together into a white paper that is accessible. If you would reach out to us, we can actually share that white paper with all of the data. But for the sake of this presentation, we summarized everything here to show you that the median age of the pumps when this was written in January, just under 15 years. I think we're at 15 years today. The mean time between service calls in the system is over 13 years. And as I think I said before, is 8 to 10 years is what we generally tell people they could expect in a pressure sewer system. Under the 15 years, we've only serviced 72% of the pumps. 28% haven't been touched yet. So that's, we're looking at percentages of the pumps serviced and then the percentages of the issues that we saw with those pumps. The median time for the first service call in these was over 7.5 years. And this project was purchased with a 5-year warranty. 18% of the issues were covered under warranty, either through a defect or if there was something that we missed on a service call or a startup, that was covered under a distributor warranty. The actual service-related issues with the pump, the mechanics, were 54% of the calls. Most of the calls, or the remainder of the calls, were either some site defect. We had issues with people hitting a panel, electrical issues, brownout conditions, and so forth. So those types of calls made up the remainder of the service call outs. And the average service calls per year for this community, including the warranty, runs between 17 and 22 pumps a year. So it's very manageable for maintenance. Our service staff, we get a notification, we go out to the site. The town generally wants to be there to see what's what, to see if there's any abuse issues, and to be aware they're basically just managing and overseeing what's going on. And our invoices detail what we find on site. So to put this in perspective, as a new homeowner now, using a home warranty, I noticed on some of the websites that 1 in 5 brand new appliances are going to break down within the first 4 years of ownership. So by comparison, in a very hostile environment in a grinder pump with a mean time between service calls of, 8 to 10 years or 13 years in history that we see, that we compare very well to the homeowner appliances that are on the market today. And also that 68% of the homes will experience a breakdown each year. It took us 15 years to service 72% of the pumps in Marion. So it speaks to the reliability of the system quite well, I think. So what's the cost of all this? How does it translate? The average cost for the first 7.5 years, which was that mean time that we saw the first call out, was around $27 a year per pump, averaged across the entire population of 471 pumps. The average cost per pump over the remainder of the total 15 years, just under $53 a year. The repair costs of the residents in Marion are covered under user fees, so there are no one-time bills to the homeowners unless there is a major abuse identified. We started out identifying some abuse, and anything that was questionable, the town decided that it wasn't worth challenging, that if we pulled a pump and it was something that was very obvious, then the homeowners would be asked to reimburse the town for the repairs. External damage to the pumps, somebody hitting a panel, digging up a power cable, were fairly small. Damage to covers, somebody hit a snowplow, hit a cover or something like that. These were a small percentage of some of the issues that we found. So that question that I was going to ask you earlier, here it is.
Okay, I'll launch the poll. What is the MTBSC? Please select A, B, C, or D. Okay, over 90% of you have voted. Leave it open for a couple more seconds. Okay, I'm going to close the poll and share the results. C, mean time between service calls. Back to you, Henry.
Okay, hold on just a second and let me fix this it won't let me switch it back. Oh. I'm sorry, I think Henry got bounced out. Come on. Henry, are you still there? He went offline. Sorry, everyone, just hold on just a second. He's getting back on now.
My network's been reestablished. Can everybody hear me now? Showing my screen. Here we
Yeah,
go.
sure.
I'm sorry about that. I don't know what happened. Good thing we're recording this, huh? So I'm back to
Capital planning. Slide 33.
thank you, everybody, for your indulgence. Technology. Can you hear me now? Are we good?
Yes.
Yes, go ahead.
Okay. So did you answer the question correctly, everybody?
Yep.
No, I was wondering how many people are going to pick A. All right. Okay, so based on the average age of 15 years, the town should begin, this is our recommendation, should begin to assess each repair against the remaining value of the asset. Doesn't make a lot of sense to put a lot of money into a pump, if it's well up in the years. Um, the casting could be in good condition. It might be worth doing more repairs and continuing the life. But we're at a point now where the town needs to look at things a little bit more carefully than they were up until this point. Currently, only 4% of the pump cores have been replaced. We keep track of in our spreadsheets that are in the white paper, how many pumps actually had been replaced. And from that worksheet that we developed, we identified about 8% that require immediate evaluation. Some of these installations had repeat calls. It could have been some installation issue that wasn't identified or may still remain out there. There could be some that were just outright abuse that continues to exist, but a very small fraction actually of that entire system really needs to be looked at immediately. What we found from the repairs that we were doing is that the mean time to the second call out has run about almost 4.5, 4.6 years. So these are certainly repairable products, repairable pumps, and things can be made to last even longer. However, as we expect as the pumps age, that time frequency might start to shorten up a little bit. But certainly spending a few $100s on a pump and getting another 5 or 6 years is well within a reasonable expectation, I would say. So the lessons learned here for these communities, and we're going to have plenty of time for questions and answers, it looks like. But each of the communities have benefited from a managed service plan. Being a contract service, the town is involved, the towns are both involved on certainly the financial collection of funds from the users, but they're not hands-on having to do the service work. This is more of a management oversight and using contract services to do the daily repairs and work. We used certified installers, certified service technicians, so you get hopefully a better repair than someone who hasn't looked at these previously. Certified installations and startup inspections as part of best practices used by the manufacturer to make sure that things are installed correctly, that avoid warranties on the manufacturer's part, avoid service issues for the residents, the homeowner, and avoid political issues with the entity controlling the system. If they don't have complaints, then their life is much better. Public education is very key to the success of these projects. People need to be aware of what they have, what's involved, and fear is something that can be a big enemy if homeowners aren't aware of what's going on, what they have. And these technologies have been around for better than 50 years. They're well accepted. They've been used worldwide, and but it may be the first time a particular community has ever seen something like this. So it's important that the residents be educated, that the managers are aware of how these systems work, have tools such as hopefully this paper and this presentation to draw on to answer questions, and provide proper oversight to reduce costs and service downtime. If you have a professional entity maintaining your system and you can manage the costs and review the reports of those providers, I think municipalities will be in a much better position. While the pumps are on private property, they really are part of the overall system. The success of the operation of the pump, whether it has a sump pump connected illegally or whether it has inflow and infiltration because it's not installed properly, those all have impacts on the receiving sewer system. So they really, in my view, should be part of the overall collection system. Whereas a pump station would be part of your collection system, these individual pumps really are part of the system. Standardizing equipment and service practices plays a major role in the ultimate success. Having standard products that are able to operate simultaneously without issue are key and important to the overall pressure sewer system design. And we can certainly help in that regard with you and your users. So for engineers, we're here to service. For system owners, we can provide backup and support. And basically, I guess I'm at a point where I can take questions and be happy to answer anything I can.
Great, thanks, Henry. Great job. And thank you all for spending some time with us today. We do have several E1 installations running all around the state and all throughout New England. So please don't hesitate to give us an email or call if you have any questions. Make sure you downloaded your certificate of completion. There's one again for Massachusetts and one for New York. Be sure you grab the correct one. There's also a copy of the presentation there. And make sure you hang on until the end when an evaluation will pop up. No evaluation, no credit hours, so make sure you fill that out. All right, we do not have any additional questions popping in. I just want to thank you all again, and please email us or call us if you need any help, and have a great rest of your day. Thanks again, Henry. Great job.
You're welcome. Thank you, everybody. And as I mentioned, there is the white paper that we've produced that if you would like, reach out to us. We'd be happy to share it.
Oh, Henry, we did have one question pop in.
Okay.
It is the cost comparison for Marion based on new construction or retrofitting a current system? Can you give a little background to the history of the project?
The Marion project was a new greenfield installation. It was abandoning septic systems. So there were existing on-site disposal systems throughout Marion, but it was a brand new construction project that was put out to bid. I don't know if that answers the question or not.
Yeah, for sure. All right. Any other questions before we sign off? Oh, one more question. Henry, can you clarify the slide on the service call for a new appliances? I didn't understand that part about 68%. I think you were speaking, E1 is built to appliance standards, but appliances today, like washing machines and dryers and dishwashers and such, right?
Correct, yes. What spurred that was when I was looking at the mean time between service calls for grinder pumps. I'm trying to scroll back to that slide now. When we look at the installation of an E1 pump or a sewage grinder pump, it's in a very hostile environment. It's in a wet environment. It's buried below grade. It's in sewage. It's very corrosive. And the mean time between service calls there being something in the order of 13 years with us, by comparison to a appliance, and I found the slide. This was something that the warranty company that I'm using for my new home has on their website, and I scrolled some other sites to see just what their projections are, because they use this to promote people buying warranties. It's like the constant hounding to get your vehicle warranty. But 1 in 5 brand new appliances are stated by this company to break down within the first 4 years of ownership. So a refrigerator, washing machine, cook stove, those are the appliances. Environment One builds their product to be like an appliance in the home. That's their mantra, is to try to make this just like any other appliance that you would have in your home. And again, stated by this company that I'm using, 68% of homes are going to experience a breakdown each year. Be it I'm waiting for my refrigerator repairman today as I'm sitting here, and you know, a new home with our homeowner warranty, and it likes to defrost at night and shut down. So, you know, I'm one of the 68% of the homes that are going to experience a breakdown this year, I guess.
I just
So
got a new
that was,
washing machine
so I was
myself.
just, I was just trying to put everything in perspective, is that, you know, these things aren't going to last forever. Nothing does. But by comparison, these are very robust compared to what we have in our homes. You know, be it a furnace, be it a boiler, air conditioner, you know, they all require some level of service.
Great, thanks, Henry. In regards to Marion too, do all the locations pump to a gravity main, or is it pumping directly to a sewer plant? Can you just give a description of the collection system?
I believe those three areas go to gravity sewers that then go to a treatment plant. So there are areas that were unable to flow completely by gravity. And there was a storm, it was the Mother's Day weekend several years ago now, where they had torrential downpours, power failures, and Marion has a system where they would go around and help people during a power failure. It's one of the common questions that residents have. And they had generators that they purchased as part of the project, and they would go around and pump people's pumps down. And the interesting thing was, during that storm, I think they had a dozen homeowners who called because they had their backup battery alarm was telling them their tank was getting full. Most of the flow that they got at the treatment plant, which was higher than their average daily flow, came from their existing gravity sewer, because the pressure sewer system, the pumps were off with a power failure, but they still saw excessive inflow in their gravity sewer.
So it was open. Okay.
Yeah,
All right. Great. Well, thanks, Henry. And thank you all again.
yeah, I appreciate
And
it.
no more questions in the chat. So just want to tell everyone thank you again. Stay on for the evaluations and have a great rest of your day. Thanks, Henry.
Thank you.